Hello everyone. In this video I will teach you how to use some properties of exponential expressions. Then we can use the properties to solve the following exponential equations. Before we go to solving, I need you to remember if we have like a times b power x, we call this coefficient and we call this base, but this is power or exponent or index. Then if we have this base b power x multiplied by b power y, when we multiply same base we add the two bases, so this will be b plus x plus y, power x plus y. For example, if we have x power 7 multiplied by x power 4, this will be x power 11, and so on. If we have x power 2, y power 3, x power 5, y power 7, we will simplify each common base. So x and x will be x power 2 with 5, 7, but y will be 3 and 7, this will be 10. Number 2, if we are dividing x power a divided by x power b, when we divide we subtract the power, so this will be x power a minus b. If we have x power 7 divided or over as a fraction x power 4, this will be x power 7 minus 3 and the answer, sorry, minus 4, and we will simplify this will be x power 3. For another example with two variables with two letters, x power 3, y power 7, x power 2, and this is y power 4. When we simplify this, we will have one more x in the numerator, this will be x power 1, we don't try the 1, and the y would be y power 3. When we combine them in one example and use a coefficient, for example, if we have 3a power 3 b power 5 multiplied by 2a power 6 b power 2 over 4a power 2 b power 4. How to simplify this? First, we will multiply the coefficients. 3 times 2, which is 6, a power 3 and a power 6, this will be a power 9, then b power 5, b power 2, this will be b power 7. When we put the denominator b power 2, then we will simplify again. 6 divided 4, they put divisible by 2, so this will be 3 over 2. A power 9 and a power 2, the difference is a power 7. B power 7, b power 4, this would be b power 3. Now you put it in the simplest form. We have different properties, like if we have x power a and this x is the base and this base is raised to power a, then all of this is raised to a different power like b. In this case, we will multiply the two exponents and this will be x power a times b. For example, if we have a power 3 and it's raised to power 2, this will be a power 6. In this case, we multiply the two bases. A different example, if we have a power 2, b power 5, and this is raised to power 4, this will take us to the next property and we can distribute the power, and this will be distributed by multiplication. So this would be 8 and b would be 20. So in the next property, if we have x multiplied by y, or x divided by y raised to power m, for example, this will be x power m multiplied by y power m. If it's divided, this will be x power m divided by y power m. Then if we have x power 0, this will be 1 in any case, except if we are putting this x as 0. So for example, 5 power 0, this is 1, 3 power 0, this is 1, negative 2 power 0, this is 1. But take care of the like tricky cases when we put, for example, 5 and x power 0 is different when we put 5x all to power 0, because this 0, okay, this power 0, we raised only the x to power 0, so this would be 1, and it's multiplied by 5, so the answer would be 5. It's different when we put it all to power 0, then we will cancel all of it and put it 1. So take care of the power 0. Number 6, if we have negative exponent, if we have, for example, x power negative 3, this will be flipped and change the sign of the exponent, and this will be 1 over x power 3. So this will take us to the next property. When we have base to power negative a, this will be flipped to 1 over x power a. Example, if we have 2 over 3 and it's raised to power negative 5, this will be 3 over 2 and the power will be positive 5. Then we can distribute 3 power 5, 2 power 5. I'm not asking you to calculate or evaluate the expression. I'm only teaching you the property. Different example, if we have 3, or let's change it to x power a, and this is x to power negative b, or we can use a different letter, it's better. So if we have 3x power a over 5y power negative b, we can keep the 3x power a, but we can flip this to be y power positive b in the numerator, and we will leave the 5 because it has a positive power, which is 1. Number 7, if we have radical expression like x power a to the b degree in the root, we will divide a over b. For example, if we have x power 3 and this is 5, we will rewrite this as an exponential expression. This will be 3 over 5. If we have this x power 2 or power 5, this will be 5 over the root starts with 2, but we don't write the 2, so it will be 5 over 2. Different example, if we have this, it means power 1 and it means second degree of the root or the square root, so this will be x power half. Now we can move to the second part when we want to solve exponential equation. And take care of this, we need to have same base and with no fraction base, then you can solve. For example, in number 2, we have same base, so we can solve the powers or the exponents. So we can take the left exponent 2 minus n, put it equal to the power right power. Then how can we solve this? We can switch between the 5 and negative n. This will be 2 minus 5, and this will be positive n, and this positive 5. Sorry, this is negative 5, yes. So this is negative 3 equals n. But in question number 1, we don't have same base. This is 3 and this is 3, and you should know that this should be also 3. So now you can think about a number, 3 to a power, which power to give 243. So you can replace this 243 by this and put same base. You can try this by the calculator: 3 power 2, 3 power 3, 3 power 4, and so on, and the answer will be 3 power 5. This is 27, this is 81, and this is 243. Now you can replace this to be 3 power 5, and in the left side it's multiplied, So I will do this in the second step so you can get it easier. Now in the left, do we have same base? Yes, we have same base, but in the left side is not simplified because we need to use the first rule. When we multiply same base, we add the powers. So we are multiplying same base, so we can put one base and add the powers. The left side, sorry, the right side would be 3 power 5. Now we have same base, so we can take 2v plus 3, the left power, put it equal to 5. Now you can solve this. 2v, 5 minus 3 is 2. Now v equals 2 divided by 2, which is 1. In this example, you can see that we need 5 to be in the base. So this is 5 power 3. We can replace this. Now we can add 5 power x plus 1 plus 2x, because when we multiply we add the powers, and the right side will be 5 power 3. In this it's 3x plus 1, and this is 3. Now it's 3x, 3 minus 1, which is 2. Now x equals 2 over 3. If you don't get it, I just added x plus 1 with 2x, x plus 1 with 2x, it gave us 3x plus 1, and put the right exponent here. To isolate x, we will send the 1 to the right side, -1, then this will be 2, then divide by 3. In this example, you can see that 32 to any power will not give us 64, also the 64, but they have common base. The 32 is 2 power 5 and the 64 is 2 power 6. So we will replace both of them. So when we replace this, it's 2 power 5 and this is raised to the original power in the question, and we keep it. Okay. Then 64 is 2 power 6 and it's also raised to power n. Now, from the third rule, when we have two powers, we multiply them. So when we multiply this would be 2 power. This power is 15 and minus 15, and this is 2 power 6n. Now we have same base, so we can take the two powers, put them equal, then solve 5. 15n minus 15 equals 6n. Then isolate this 15n. We'll take the 6n the left side and we will send this to the right side, 15. The difference is 9n over 15. Now we can simplify this to be n equals 15 over 9, which is 5 over 3. Number 7, we need to subtract the power because we have division. So this would be 6 power 2n minus 3 minus negative 3n, which make it positive 3n. In the right side, this will be 6 power 3. Now we have two equal bases, 2n minus 3 plus 3n equal 3. 2n, 3n, it's 5n. When we send the positive 3 to the right side, this will be 6, and the n will be 6 over 5. Okay, the idea that we didn't take is when we have fraction, because I wrote at the beginning that we need no fraction base. So we can do this. Look at this. You know that if this was 64, the 64 is 4, like this, power 3. Okay, but this is not 64. It's 1 over 64. Do you remember the property that flipped the base? So this could be 4 power negative 3. And because of this negative, it's flipped. So we can replace this to be 4 power negative 3. Now, do we have same base? Yes, we can take the two powers, put them equal, then solve. 2a, and this is positive 1, equals -2, then a equals -2 divided by 2, the answer will be -1. Same idea. Okay, yes, we have same ideas. I can do this for you. This half is 2 power -1 raised to power -3b, and this is 2 power 4 raised to 3b minus 1. So this 2 will be positive 3b when we multiply, and this 2 will be 12b minus 4. You can take the 2 powers and solve. Same idea, 4 power -2. This is 25 power -2, because 25 squared 625. Or you can put them as for the base 5. Okay, this is everything about solving exponential equation. It's not the hardest type of questions. We may have like advanced levels, but when we study another topics next next quarters, inshallah. Thank you.